triglycerides. Is that correct? The triglycerides could be. That's called the stereospecific number 1, that's stereospecific number 2, stereospecific number 3, and the arrangement is specific. Is that right? Some of them, or let's say egg yolk, sometimes the middle one is unsaturated fatty acids, sometimes all of them are saturated fatty acids. It's a different combination, will have a different products. And then the fatty acids quality will be different. Now, bacteria can use that if they have the enzyme called lipase. Now, how are we going to do it? We have split blue agar. The left side, we inoculate E. coli. Right side, we inoculate Bacillus subtilis. And then we do the incubation. We want to do the incubation, we still do 25, 48 hours. If you see a transparent zone surrounded by one bacteria, that means it is positive. So hope one bacteria could be using lipase. So that's how we do this first one. It's very easy. You have E. coli, and then you also have Bacillus subtilis. And the agar split them onto two. Left side inoculate E. coli, right side is inoculate Bacillus subtilis. Now, of course, you have to do the label by yourself. Okay, don't forget the label. So that's the first test. The second test, starch. That's starch agar. Okay, bacteria can use starch. Starch is disaccharides, a little bit above from the structure points, more advanced than glucose. There is no difference compared to all the others, looks like. So what is starch? What are the major components of starch? Anybody? Amylose and amylopectin. So how the amylose they connected? One-four glycosidic bonds. Is that right? These are two glucose. Just draw briefly. That's amylose. What's the amylopectin? A glucose, and then you draw the other side. You're going to be like this. We go this here. There you go. CH2 comes out, connected with these. That is called 1,6 glycosidic bonds. And also the ratio is important. Is that right? In the product. So I'll give you a joke. You go corn maze. Some kids are very naughty. They have a bag to store some of the corn and go home cooking and never can eat because it has a high amount of the amylose. Is that right? It's resistant starch. So, but the general sweet corn, the amylopectin is higher. So the different products, the ratio is different. And remember, what are they looks like? This is amylose, and amylopectin looks like this. And then they could be connected. When you have a water there, it's going to be like that. And then you have a pasta. The pasta you put in the boiling water, and all these gonna be leaching out, and then it's gonna swelling. Is that right? What this called? Gelatinization. And then you cool down, the pasta will be shrinked a little bit. That's called a ritual degradation. Is that right? That's in the chemistry. So that's for starch. But bacteria can use starch. Same thing. Left side, we inoculate E. coli. Right side, we inoculate Bacillus subtilis. Okay, what's the difference compared to that? You're not going to see the transparent zone. You have to do the confirmation test after incubation. 25 degrees Celsius, 48 hours. Which reagent starch will be reacted? Is iodine. Is that right? We use iodine value to evaluate the presence, absence of starch. And most of the time it's brownish color, but not really. It depends how long the starch. If the starch has like 10, 12 units, usually it's brownish color. If it's more than that, let's say like 25, 24, usually it's red. But basically we say it's a brownish color. So after incubation, we need to pour the iodine reagent. If one side you show brownish color, what this means? Means the starch is still there and the bacteria is not used. So we need looking for the side is non-brownish. Then what this means? Starch has been used. So how we break down starch? Which enzyme? Which enzyme is for starch? Lipase for lipids. Which enzyme? Which enzyme to break down starch? Is that called amylase? Yeah, amylopectin, amylose amylase. So amylase. Well, there are different type of amylase. Okay, that could be talked about 20 minutes, so we just skip that. So some break down the 1,4-glycosidic bond, some break down 1,6-glycosidic bond, sometimes break down amylose, some break down both of that. That could be talked a lot. Amylase. We say generally it's an enzyme. If bacteria has amylase, it will break down starch. Then once they break down starch, it becomes what? Glucose. Or dextrose sometimes, it depends. Disaccharides become monosaccharides. So what do we show up on the agar? There's no brownish once we pour iodine. So this twists your mind a little bit, okay? If on Tuesday or if on Thursday, you adding iodine and you see brownish color, which means starch has not been used. So amylase test negative. And once you see the area is no brownish color, which means starch has been break down, then becomes what? Glucose. So that's amylase test positive. Okay, so that's the one. Last one. We have a skim milk agar. Okay, same thing. But skim milk agar looks very milky. Looks like this. And you can see the difference. So the question is, it's easy to do. Left side, we inoculate E. coli. Right side, we inoculate Bacillus subtilis or Citrobacter. And what we do? We incubate, and then we look for transparent zone. Now the question is, what's the skim milk agar testing for? So think about what means skim milk agar. What we have in the skim milk? Of course, you have water. So what you have? You have protein. What is the protein in the milk? That's called casein. Is that right? So if bacteria has an enzyme called caseinase, or in one of the proteins, it will break down protein, become peptides, and later on become amino acids. But the question is, why will you skim milk agar? What do you skim? That means 0% fatty acids. So we don't want the fatty acids there because otherwise it's going to bother you. So we use 0% milk, fatty acids milk, that is called skim milk. So you go to the grocery store, you get a bottle of say whole milk. What's the percentage of the milk? That's 8%. And you get a reduced milk bottle. What is the percentage of the fatty acids? Sometimes 5%, sometimes 2%. And then you get a skim milk. It looks like a water. It's very like light white because ideally 0% fatty acids, and you use extracted methods usually do. Is that right? So that's what we do. And what's the components inside of the milk? The sugar is called lactose. That's why we have somebody cannot drink milk. You have a diarrhea, vomiting. You mean not really vomiting, diarrhea, nausea, because of lactose intolerance. You don't have glycosidase. Okay, I want to have some reaction. Okay, that means your chemistry is good. We are talking about biochemistry. So, again, these tests are very simple. And you inoculate the bacteria, then you see the transparent zone, but the story behind it could go further. Okay, so we want to do these things. Now, I also want to mention like lipase, it is important. That is in the food industry is important. Why? If you have a processing of meat products, we want the lean and the fat in a good, appropriate amount. You don't want the beef is very fat. You don't want the muscle is too lean, because sometimes you cannot bite it. So we talk about juiciness, tenderness, and the flavor. During the processing, sometimes we using the bacteria have lipase, and it could be adjust the ratio of the lean and also the fatty acids part to make the perfect products. So that's why there is some application for using the bacteria strings during the food processing. Okay, so that's all we're gonna do. Okay, again, everybody come to here. I'm gonna show you how to do. Because I want to be, everybody can get it. Okay. So you will become here to get, let's say you get E. coli, you get Citrobacter, and you get the Bacillus, and using you rat. And again, we haven't done the agar for a little bit time. Last time using a little, did a little bit of the oxidase test to use the agar. This is very wet. Look at these. So don't forget, this you have to do. Okay, I'm remind you all the time. Lots of people doesn't realize it. And this inside, this inside looks terrible. So clean it. Okay, that's this thing. Now, you can all do it at the same time. Where's the sharpening block? Okay. You can do everything like this. EC, E. coli, Bacillus subtilis, Bacillus subtilis, Bacillus subtilis. Your initial in the side, initial date, 1028, initial bench number date, Although it is on your personal tray, we're still gonna do it. Okay, once you do this, so you can see it. So that has to be done later. Okay, you cannot see it. See, it's still. And then what you do, this time you still use loop. Okay, hope it works. Okay, not too bad. So what we do it. I just gave you one example. Okay, flame the loop. You have flame it, cool down, pick bacteria, flame it, put on the side, and then you can do like that. Okay, if you want to save time, flame the loop, pull down. There you go here. That's save you a bunch of time. This you have to be careful, because you want to see at the back, okay? Every single one you still have to be changed. So, flame the loop. Touch the bacteria, the last one. Right here. Okay, now. Flame the loop again. We're going to do the Bacillus subtilis. So we have a Bacillus there. Touch the bacteria. And then go here, very gentle. That's all. We want a certain amount, so we flame it. Between the agar plates. Then go here. Flame the loop again. And the last one. That's all. And that's finished. And then give this to you. Well, just keep on your tray. Okay? Like this. Before you go, flip it over. Now, this is a skim milk agar. Skim milk agar, you do E. coli Bacillus subtilis. This is the one which is E. coli Bacillus subtilis. This is the one also E. coli Bacillus subtilis. But one bench, we can have one student do E. coli and Citrobacter. Let's say what it looks like. Okay, so you have one representative do E. coli and Citrobacter. Then we'll see on Thursday what it looks like. Maybe no difference in E. coli. Maybe there's a difference. Because we know Bacillus subtilis is a very good enzymatic activity bacteria. But we don't know Citrobacter what it looks like. So we can do it. So one bench has one representative to do Citrobacter with E. coli. Others we do E. coli and Citrobacter. Okay.